All right, let's do 4.1 day 2. And you'll notice I added 20 because we did so much talking about it in class. I want to make sure we get that. So let's start off with 51. So 51 asks you to first find g of f of 2. So I guess I first find f of 2 by going to the f function, plugging in 2, and I get an output of 4. So this is just 4. So then I find g of that. Well, what does g do? G of 4, if you plug in 4 in g, you get out 2. So that's your answer. Next is 53. 53 asks you to find f of g of 1. So that means first, if I erase this now, first it wants me to find g of 1. So I go to the g function and plug in 1, I get out 1. So then I take f of that. So I take f of that answer. So I take f of the answer 1, and I get 1. So it turns out to be 1. That's 53. And then 57 is a little more ridiculous. It asks you to find, for 57, it says please find f of g of f of -2. So the first thing I do is I plug in -2 into f. So let me erase everything. First plug in -2 into f. And -2 into f gives me out 4. So this is just 4. So I'm taking g of 4 and then f of that. But g of 4, if I look at the g function, if I plug in 4, I get out 2. So this is just 2. I'm really taking f. I'm taking f of that 2. So when I look at f, I'm really taking f of that 2. So I plug in 2, and I get out a 4. So this is just 4. All right. So now I'm ready to do 59, 61, and 67. So 59 asks me to find f of g of 5. So I'm going to first go to the input of 5 and plug that into g. So for the input of 5, if I plug it into g, I get out 8. So this is simply 8 that I'm taking f of. So now 8 is my input. If I put 8 into f, I get out 9. So my final answer is 9. So that's 59. When I go to 61, if I erase this, now if I go to 61, it wants me to find g of f of 3. So first place I go to is an input of 3. So here's an input of 3 because it's an x. So an input of 3 into f gives me out 8. So I'm really taking g of 8. So if 8 is now my new input, I'm really finding 8 is the input, plugging that into g, and I get out, yes, you guessed it, 4. So that's 61. Now I need 67. 67, which, if you'll allow me to take a picture, so for 67, I need to look here at this table. So here is table number 4. Say done, save it to photos. So when I go back to my app, I can now paste a photo that I just had. And for number 67, it just wants to know if you understand the notation f of g of 2. So f of g of 2 just means to do g of 2 and then take f of that. So if my input is 2, I look at a positive 2, plug it into g, and the output, boop, for g, the output for g is -3. So you get -3, I'm going to take f of that. So if -3 is my input, I take f of that, I get 11. So that would be 11. Now I'm ready to do number 20. So we're going to go back and pick up number 20. I put it at the end because it's a little more difficult. I just wanted you to get your sea legs. So first, if I've got f of x is equal to 1 over x, and g of x is equal to x minus 3, And what it wants to know is, first find f of g of x. Well, I know that means to find g of x and plug it into f. Well, what is g of x? It's x minus 3. If I plug it into f, it's going to be 1 over whatever I plug in. But here I'm plugging in x minus 3, so there's my function. If I find the domain of this, well, here's my new function. Its domain is going to be that the denominator cannot equal 0. So I set the denominator equal to 0 and find out it's not allowed to be 3. So you can't be 3, but you can be anything else. That means it's going to be negative infinity to 3, and then 3 to infinity. So that's part A and part B. And then for part C, it wants me to find g of f, which I just know is first do f and then do g. So f is the function 1 over x, which I plug into g. What g does to things is it takes what you give it and subtracts 3. I think it's pretty clear here. If I find its domain, well, its domain is going to be where, again, the denominator cannot be equal to 0. So I think in this case, the only fraction I have is this 3. Maybe it makes sense to hit this with an x over an x, to where I have 1 minus 3x over x, if that's pretty. So I don't want this denominator to be 0, which is still x. So x shouldn't be 0. That means that you don't want to be 0, but you can be anything else. So how about negative infinity to 0, or 0 to infinity? Again, this step I did right here, I just wanted to see what the function looked like as one term. That's just a nice thing to do, but we didn't have to do it here. And then E is an egg. It just asks to find f divided by g. Well, we said our f function was 1 over x. When you divide it by the g function of x minus 3, well, how do I divide it? Just think of the bottom as over 1, and you have a compound fraction. So now what I'm going to do is I'm going to take the top fraction multiplied by the reciprocal. So now I have the function 1 over x, x minus 3. I think in this case, it didn't ask us to find the domain, but if you did want to find it, its domain, we would not want the denominator to be equal to 0. So I'd set this equal to 0, which means x can't be 0, and x can't be 3. So you take your number line, not your fraction, take your number line and say you can be anything but those values. And it didn't ask for the domain, but we could say that the domain is from negative infinity to 0, 0 to 3, and 3 to infinity. Have a great day.